Hi everyone, my name is Thomas Kim. Today is July 5th, 2022. This is my 24th episode about C++ 17 2023 CUDA SQL OpenGL OpenCL TBB. In this episode, we will learn how to cook std tuple with posterion and tuple. I assume you have installed C++ library extensions. If you haven't installed, please double-click this link. I updated C++ library extensions today, July 5th. You can download by clicking this link. Also, you can learn how to install C++ library extensions on Windows. Please understand that this library supports Windows operating system only. It does not support Mac or Linux or Unix system because I use Windows API functions. I also assume you have watched my previous video, episode 23. This video, we will pick up where we left off from our previous episode. So if you haven't watched my previous episode, you may have difficulties following my current session. Show more, scroll down. You can click episode 23 source code download, this link. Show in folder, I downloaded multiple times. Unzip it, rename episode 24 for Stallion. Copy the folder path, copy, paste it to your working directory. Now start Visual Studio Code. In the File Explorer, from folder 24, double-click this file, Ctrl V. We created this file in our previous episode. So if you haven't watched my previous episode, you may not be able to follow my current session. I will use these libraries all the time in the future sessions. Now scroll down. Here, void test advanced tuple addition. Copy this function name, copy, paste it here. I will disable it. We are given two tuples, std tuple A. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Copy, paste. This is tuple B. This is 2.5. This is 8.5. So two tuple. We want to add two tuple like this. Auto C A plus B. How? We can do like this. Namespace std. So we open namespace std because tuple is defined in the namespace std. We have to open namespace std because of a d l or argument dependent lookup. Here, template, type name, ele types 1, type name, ele types 2. We will use constraints, requires, or we can say size of ele types 1 equals ele size of ele types 2. The size should be equal. We have to use parentheses here. Then auto operator plus std tuple ele types 1 constant L value A. Copy this, paste. This is ele types 2. This is B. I misspelled operator. Please understand that ele types 1, this parameter pack, ele types 2, this parameter pack should be different. Now, context per or n size of ele types 1. We constrained the element types. The element count of tuple should be the same. Now, talk play fun types for tuple. We pass n, then some lambda, return. We define the lambda here, or OPR. We capture A, capture B, or I. Don't miss semicolon here. Return std get I index A plus std get I index B semicolon. We are adding two tuple element wise. Then we pass this OPR here. Please understand that this addition operator can be anything. You can define arbitrary operator with arbitrary semantics. This is just for demonstration purpose. It can be any operator. For example, like this, or like this, or type. As long as it is binary operator, it works perfectly. Now we can display the result std cout a std and copy paste. I need to delete this. It can be B A plus B. It is C. I will arrange like this. Now you can open any compiler. I will start with Intel compiler CD 024 for Stallion DP CPP SED C++ 20 or 23. For the time being, I will use C++ 20 standard. Don't miss EHSC, fno, SQL, or d.exe. Hit enter. I missed the input file. Mode cpp.cpp. Hit enter. CLSD. So tuple A 1, 2, 3, 4, 5, 6, 8.5, something like this. 1 plus 1, 2. 2 plus 2.5, 4.5. 3, 3, 6. 10, 10, 20. It works perfectly. Now pay attention to here. SED tuple 6, 7, semicolon, copy, paste. It can be 7, 6. Please note that the element count should be identical. Okay? And element-wise operation addition should be supported by element-wise because this plus operator is recursive. Once again, this operator is recursive. This is a function. If index element of A, index element of B are tuple, then these two tuples are added. We build again. CLSD. So 6 plus 7, 13. 7 plus 6, 13. The type can be different. This is double, this is float. The type can be different arbitrarily. Build again. CLSD. It works perfectly. Now here I will copy and paste. Copy, paste. Now it can be subtraction. Then it should be subtraction. Here we can say or D C minus A. Then here C minus A D. It should be B. We will try with the clang compiler for stallion. Clang plus plus SED C plus plus 20 mode cpp.cpp ltbb 12 or c.exe. We are using clang compiler CLSC. So with subtraction, this is identical to B. Now I will copy this, paste. We will be using multiplication, but instead of for tuple, we will use for stallion like this. Return CPG types for stallion. We pass n, then we capture A, B. We can use auto I. Then CPG types sequence. We expand I. Semicolon, curly brace, semicolon. Here return std tuple std get I A multiply std get I B. We have to expand because I is parameter pack. This syntax is supported since C++20 standard. Don't miss semicolon. We defined multiplication. So auto E equals C times A minus B. This is effectively A plus B times A minus B. Now we copy, paste. This is E, E. We build again. CLSC. So E works perfectly. Why it is 0? Because A minus B is 0. A minus B is 0. Certain element types are 0. If we change into something else, for example, here, then this is correct calculation. Now, this is not 0. The takeaway of this session is that this multiplication operator, this addition operator, this subtraction operator does not need to be multiplication or subtraction or addition. It can be any arbitrary operation. This is just for demonstration purpose about how to use for tuple, for stallion. Since we defined CPT, CPG types, we can change like this. It's much shorter and compact. In the same manner, since we defined TPT to be tuple fun types, it's much simpler or simpler. Don't underestimate this programming technique. I am not interested in addition of two tuples. What I am interested is recursive function call using these binary operators. We can arbitrarily extend our algorithm using these recursive operators in modern C++. I will be using for stallion, for tuple all the time in future episodes.